Hi everybody, this is Evergreen Hacker, and we are at Leetcode.com again. This time I wanted to look at a weekly contest. The contest already finished and those guys won. Congratulations to them. But we will solve issues which they try to do. This is the first one. It's easy. Yeah, but by the description and examples doesn't look like that. But let's go ahead. I'll give you some time to read the description. Okay, so yeah, you probably read that and say, what's that? What does it mean? Let's quickly go through the example to understand that. Yeah, by the way, there's an issue here, like function f is on B actually, not on A as written here. But yeah, we can skip that. So, example. It's much easier to understand this task by looking at the example. Here we have a function which takes k as an argument, and k can be any value from 0 to n minus 1, where n is the length of the array. We have an array, of course, and this is just a weighted sum. So we just need to understand which weights produce the biggest f. And we can solve that in a brute force way, but you can look at the node, and it's quite big. It can be up to 10 in the power of 5. So it's better not to do the n square algorithm. Why n square? Well, because brute force means that we just try to calculate that stuff for k equals 1. Then we try to calculate that stuff exactly using this formula. And then that. We will have n by n operations because we have to do n multiplication for n different values of k. Yeah, so let's try to remove the burden of multiplications. To tell you, I've tried the brute force way and it fails with time limit exception. So it's better not even to try. So let's do the optimal solution straight away. As usual, we are starting with an example, and we will understand how to do this by looking at what happens with the sum, because eventually we have the sum here, right? What happens with value f, and can we use the previous value of f to calculate the next value of f? Let's see. What I notice here is that those guys, they are shifted to the right. Yeah, but that's expected. That's what's written in the description, right? But it means that for the F1, we can reuse F0 at least to those guys which are written here. So for those which were not removed or multiplied by weight 0, and not for those which will be shifted to the 0th position and will be removed, basically. But for those in the middle, can we reuse F0 for them somehow? Yeah, I guess yes, because if we look at those guys, they moved here, right? And if we rewrite that, it will be 1 multiplied by 3 plus 3. And this one is 2 multiplied by 2 plus 2. And then look here. This is exactly the guy. And this, yay, this is exactly the guy. It seems that we can reuse this result and just add the simple sum for the array, which can be written like this, sum of A, which for given A will be 4 plus 3 plus 2 plus 6, and 4 plus 6 is 10, 3 plus 2 is 5, so it's 15. So we can rewrite that a bit differently, and we will say then f1 equals f0 plus 15. So we are adding, or let's say sum of A, of all elements of A, and then we have to remove some stuff. We have to remove this guy, minus 18, or 3 multiplied by 6. Look at this guy, maybe we can reuse it as well. Yes, we can, because it's the same plus 4. So it means that we can reuse sum of all elements of A for all of the elements except for the last one. And what are we missing here? Are we missing something? So remember, this sum is a sum of all elements, including 6. But we only reuse 4, 3, and 2. So those guys. And we don't need 6. So we have to remove 6 again. And it can be rewritten as 1 plus 3 by 6. Looks like a good formula. And we can try debugging. Remember, we have super powerful debugging. So we can try that. But wait a minute, we haven't written anything yet. Yeah, well, we can debug even without writing a piece of code. We will put f0 is 25, we know it from here. And then we will put f1 equals f0 is 25 plus 15, we have it here, minus 4 multiplied by 6, which is 24. 24. And what do we have here? 25 minus 24 is just 1. It will be 16. Wow, so we have 16 and 16. Nice. Let's try calculating same stuff for f2 and compare the value with the f2 in example above. So in this case, it will be a bit different. It will be f1 because we have to calculate base of the previous f. Then this one is the same one, it's constant. And this, yes, something changes with this guy. We have to replace 6 with something else. Look at the array. For unshifted version, like this one, we have values 4, 3, 2, and 6. But for shifted, 6 goes to the beginning. And then we have 2 here. So we have to put 2 here. Okay, let's calculate. F1 is 16 plus 15 as before. Yeah, let's actually put it here so then we don't mess up. And minus 4 multiplied by 2, it's 8. So what is this guy? Okay, I know that 16 minus 8 is 8, and 8 plus 15 is 23. And let's calculate F3 before we going up for checking the results, because I know you will pick and look at result for F3 as well. So let's modify this guy a bit. f out of 2, and then who will be f a prime prime. 2 shifts here, so it will be 3. And what is it? It will be 23 plus 15 and minus 4 multiplied by 3, which is 12. Okay, so this guy is just 3, it's 26. So we have to check 23 and 26. Ha! 23 and 26. Nice, right? So seems to work. Now let's implement that stuff. What do we have here? So first, sum of a. Let's just call it, guess what? Sum of a. And thanks to Python, it already has a sum function, which we can reuse. Now, we need some kind of loop, but usually loop starts with 0, and in this case we would have to modify it a little bit and start from 1, because as you can see in our recursive definition of f, we look at the previous value. So when we are at the first iteration, we will have no previous value. So we have to calculate previous value and start from the second element. So let's calculate that, and let's just call it previous f. What will that be? It will be this thing, right? So should be something like that. Well, we can just say that it starts with 0, and then we just do the for loop for I in x range, range of n. We say pref f is going to increase by a I multiplied by I, right? That's it. Yeah, so I wanted to tell you that this is the nice and slim way of writing stuff, but there is a slimmer way, and some pro guys may want to replace that with something fancy like reduce. We can do that as well. Reduce takes 2 or 3 arguments. The first one is a lambda, which takes 2 arguments. First is accumulator, and second is item, and we do something there. Then second argument of reduce will be an array, so we are passing a, and then optional third element is the starting value of accumulator. So let's just put that stuff there and replace I with it. And now we have to return a new accumulator. So we just say old value plus this extra weight node. Okay, so that should work equally. It's up to you guys what to use. We can try both of them and see if it works equally. So done the first step, and now we have to do the for loop to calculate maximum value of f. For maximum value, we have to initiate it with the previous value. Now for loop. Let's call it k because we know it's the name of the argument for f. In x range, and now we have to start with 1, not with 0, because we are starting with the second iteration. We missed the first one, or skipped the first one. Okay, let's go. Pref f So what we were doing here, we were saying that it was previous value plus sum a plus, what's that? This is actually n, yeah, multiplied by what? Yeah, multiplied by what? So now we need to find who is staying here on the last position for the previous iteration. Yeah. Okay. Let's see. Let's just draw it here. For k equals 0, so we know that this is for k equals 0, this is for k equals 1, and this is for k equals 2. So for k equals 0, this index, let's call it carry index, because it will be carried here. So carry index is just n minus 1. Then for this guy, carry index is what? Is n minus 2. Because look, it's this one is n minus 1, this one is n minus 2, and now n minus 2 becomes n minus 1 in a prime. But we don't care about indexes inside a prime or a prime prime. We just need to know what is the index in the original a array, and it's n minus 2. Whoop. And let's just check it out. So n3, n minus 3, it's actually 4 minus 3 is 1. So yes, that's 0, that's first, that's second, that's third. Nice. So formula seems to work. But now remember, we can have carry indexes be negative, can we? No, I think we cannot. But just in case, we will use mod operator if we have some overflows of some kind. So carry index equals n minus k. Yeah, why k? Because look, here we will be at some k equals 2, for example, and we will be looking at the carry index for the previous iteration. And in this case, it's n minus 2. And we have k equals 2 here. So 2 and 2. And it works for k equals 1 as well. 1 here, 1 here. So we can just say k minus k, n minus k. And as I said, let's just take the module of that stuff by n. And is that it? Yeah, we've calculated previous f. Do we need to do anything else? Yeah, we have to check if max f is smaller than or less than previous f, then max f equals previous f. That's it. Return max f. So how do you think? Should I run it straight away? Yeah, let's see. We have sum a, which is okay. We have previous f and then previous f calculated here. We have max f. We have k in x range 1 of n. Oh, we don't have n here anywhere. What is n? Nice. So we have to say n equals len of a. Nice. What else am I missing? Let's see. Current index is n minus k mod n. Then previous f equals previous f plus sum a. Oh, what's that? Yeah, sure. We have an index, but we don't access the array with that index. Okay, so now we do. Then max f, previous f, yeah, those guys are defined. Seems to be okay. Less, yeah, less should be fine. Okay, let's run now. Yeah, so it worked on some test case. Let's submit the solution. Wrong answer. Wow, my output is 114. Yeah, I shouldn't have been that optimistic. Okay, let's debug. First of all, we have to understand if I'm writing the proper thing here. So, in x range of n previous f, yeah, seems to be okay, right? Because index will be 0, 1, and 2, and so on, and values will be 4, 3, and so on. Then here, previous f, yes. Then here, n minus k, n minus k, yes. And then here, previous f. Oh, we have pluses everywhere, but we used to have minus here. So let's put a minus here. Nice. So now let's debug. Let's start straight away from this guy. Sum A equals 15, that we know, and I doubt that this function actually fails. N equals 4, previous f. So previous f should be, for 0 element, it will be 0 multiplied by whatever, we don't care. Then 1 multiplied by a1. So let me copy this guy over here. It will be 3 plus 2 multiplied by 2 and plus 3 multiplied by 6. So that's exactly what was written here, and we know it's 25. Okay, then let's go over here. Max f equals 25. Then k equals 1. Then carry index. Index. Let's check it out. It's n minus k, which is 4 minus 1. Blah, blah, blah. Yeah, I think we don't need mod, but let's keep it there just in case. So it will be 3. Then this guy, previous f. So now it's 25, but it will be recalculated with 25 minus 15, plus 15 minus 4 multiplied by a3. What is a3? It's 6. What is that stuff? It's 24, and it's 16. So we are running good, I think. Yeah, that's the same stuff as before. Then if max f less than previous f, no, it's not. 25 is greater than 16, we don't do anything. Okay, so I think now we are correct, and we can just submit solution. Yay! Accepted. We have a few more exercises here, so please open other videos from this playlist and subscribe to my channel. All the best to you, and good luck at your interviews. Don't forget how to debug on whiteboard and try practicing a lot. See you guys. And now a bonus for those guys who wanted to compare this nice reduce to even nicer and potentially much better understandable for loop. Python allows this one line for loops. Let's try and see if that works. Yay, that works. And now let's comment this guy, uncomment this one, and see if it works. Oh, nice. So I was bullshitting you. Let me see. Yay, obviously. We have to have an X range here for n elements because we are accessing the elements of array A right here. We don't need to loop over them here. We need to loop over indexes. Okay, let's try again. Yay, accepted as well. Compare those two lines with this one line. What is better? It's hard to say. If you are programming on the code base yourself, probably this reduce will be easier for you to understand it later, and it's shorter to write that. But if you want to share your code with a lot of other guys, then I would recommend to use this a bit bulkier version of writing stuff. Not because I'm old-fashioned, but I know that others may be old-fashioned, and okay, I'm also old-fashioned, but others may also be old-fashioned, and then when they look at this, they will take maybe 10 seconds or so to understand what that stuff is doing. While if they look at this, it will take them maybe 3 or 4 seconds. I don't know. Maybe I'm just bullshitting you again and making things up. But still, this is an old way. Everybody knows what's that. This is a fancy thing which maybe not everybody knows. Okay, with that, see you later. Bye bye.